I've never presented a forecasting thing, so I don't know how to address. I guess everybody in here is the governor. So we are group 2 and we are doing a macroeconomic forecasting and analysis on South Korea using various econometric methods. So just a brief overview of the data that we started with. So the main variable that we were focusing on was GDP, and we would have also looked at some sub-variables, so CPI, the real exchange rate, interest rate, retail sales, equipment and equipment investments. The frequency we worked with was quarterly and monthly data, excluding GDP, which was quarterly. The period that we looked at was 2000 Q1 to 2024 Q3. So looking at the first graph, the data is obviously non-stationary and it also seems to have a trend. Oh, for some reason you can't see it, but yeah. So this is GDP in the blue line and the orange line is the GDP seasonally adjusted. So we would have taken the log and the first difference, which is the second graph that you see there, and that would have produced some stationary data, and that was tested using the ADF and the KPSS with trend and intercept, which did indicate stationarity. I know it's a bit noisy, but that is the case of GDP data. So the first output that we would have done is the ARIMA forecast. The ARIMA forecast was chosen using eViews. They would have indicated that an AR4 and 3 model was the best forecast to use going forward. And we would have also included 2 dummy variables, one for COVID and one for the global financial crisis, and that would have helped to smooth out the data a bit. We can see here that the results are not good. The R square is quite small, and the probabilities for the AR and MR terms are not the best in certain instances. Well, when we looked at the unit root test, it showed that all of the AR terms would have, the ARMA terms would have fallen within the unit root, so that could not have been the issue. And then finally we have we would have run a simple forecasting result, and the root mean squared error term is very low, and the Thiel coefficient is greater than 1, meaning that this model is specific, it would not be even a naive model. And we say that it's because perhaps we did not have enough data for this for the GDP. A GDP using an ARIMA forecast is not the best, especially if the frequency isn't high enough. But in our case, we only had about 100 observations for us specifically, but it seems that we would have needed much more to have a better outcome. So the ARIMA model for us did not work out, but it's important to show, I think, your failures as well as the successes that you would have had in your model. I'm going to turn it over to the people that did the VAR and Beckham.
Thank you. I would like to present the estimation and forecasting results of VAR and Beckham models. First, I want to introduce the variables used in models. As Melissa already told, I used RGDP and retail sales index and equipment investment index. The rationale behind this selection, by incorporating retail sales, I aim to capture the movements of private consumption, which is key component of GDP. And similarly, I including equipment invest index, I try to reflect the investment movements within GDP. Looking at the variables, all the 3 exhibit trends. Since they are non-stationary time series, I applied log differencing to all of it. And next, I will present the results of the log differencing. The log differenced variables are all satisfy stationarity, and I confirmed it by KPSS test and ADF test. Next, I will discuss the estimation of the VAR model, and using AIC information criterion, I set the leg length to 1. The figure on the right shows the estimation results. Using the estimated VAR model, I forecast from the first quarter to third quarter of 2024. The forecast results show the RMSE is lower than that of ARIMA model, indicating improvement of predictive power. This improvement appears to be due to the use of multiple variables rather than a univariate approach. Next, I examined whether the variables have a cointuiting relationship using the Johansen test, and the results indicated that there is a one hidden long-run relationship among the variables. Using the long-run equivalent relationship, I estimated the backend model, and the figure above shows the forecast results are from the estimated backend model. However, when examining the forecast results, we see that they are not different from the VAR forecasts. Additionally, the RMSE values are nearly the same. The reason for these results can be observed in the estimated coefficients. Looking at the coefficients for GDP in the long-run equivalent relationship, we can see that its magnitude is very small. In other words, because the force driving to the long-run equilibrium relationship is weak, so that the results are essentially the same as those of VAR model. And thank you.
Next, I'll just we just included a structural VAR as well. So unlike the reduced form VAR, which is done for the forecasting, we have done a structural VAR for policy analysis as well. So we just followed the Cholesky decomposition, ordering where the monetary policy rate, if there's any shock or increase or decrease to monetary policy rate, what would be the effects on the inflation, exchange rate, and the GDP as well. And since South Korea is a very open economy with a lot of exports and trading with other major countries, we believe that the exchange rate would also have quite a big impact on the GDP as well. So going forward, unlike Kim's equation, we went for a monetary policy rate and inflation, which is derived from the CPI, and the real exchange rate. So we did a log and difference the log of the real exchange rate, and computed the GDP gap using the HP filter as well. So as you can see in the model, some of the variables, although like monetary policy rate, even if it wasn't stationary as a variable, we considered to go ahead with it because within the system, it showed that all the roots were within the circle. So it was stationary for the VARs. So for this one, I'll just explain from the left. So when there's a shock to the monetary policy, where like when we try to increase the monetary policy rate, we believe that the inflation is increasing. It goes for during fourth quarter, like it takes the time, some time to increase the inflation, but over the time it comes down and stabilizes. And similarly, for the exchange rate as well, it's appreciation, which means like their exports are valued higher and their imports are valued lower. So they might be increasing their imports, and they might have that's causing their real exchange rate to appreciate a lot, and then it's going down. But after some time, with the shock, it stabilizes in the future, like in after like. So at the same time, it can increase the GDP within the 1 or 2 quarters, but over time, the GDP is going down with the increase in monetary policy, right? So that's it, and then we'll continue.
Okay, good day everybody. So I'm gonna talk briefly about our estimates using nowcasting. So our primary goal is to nowcast the real GDP of South Korea as of Q4 2024. And we used, as was shown in the workshop in the last week, 3 main models: the breach model, MIRAS, UMIRAS, and we did combined estimates as well. We used these data. So as Yunjae and Milicia have shown before, DLOG of RGDP and other variables have been tested for unit root. But in this case of nowcasting, because I used different variables, I did the unit root tests on these variables as well. So the different variables that was chosen was industrial production index, and also central bank's asset holding, COVID dummy variable, and Kospi index of Korea, and also the retail sales index, and all of which except COVID and RGDP are monthly, has high, i.e. monthly frequency. So I had to convert them into quarterly frequency using temporal aggregation methods. For RGDP and COVID, there weren't any changes. For central bank assets, I used the last observation, industrial production indexes, and RSI, I used the average estimates, whereas for the Kospi index, I used the last observation. The reason why the average estimate was used for the retail sales index was that because this index sort of shows the micro behavior, if you will, of the households and the consumer lending. So that's why, in order to avoid losing an important dynamic information within the 3-month period, I just took the average estimates. So if you can look at the dynamics of the chosen variables, if we take the first difference of the logs, you can see it's fairly stationary. So that's the estimates of the unit root tests that have been used on the variables that had not been estimated by our teammates. So the strategy of the estimation was that basically because it's a different country, I feel, even though nowcasting is a reduced form model, I feel like people still need to understand the dynamics and the peculiarities of the country, unique features of the country before going ahead with the model estimation. So we try to understand the country's unique features and then go ahead with the modeling. But still, that said, the first step for us to was for us to replicate the workshop model of the Australian case that was used using the similar variables, but in the context of Korea. So in this case, we used all the similar variables like Kospi index, industrial production index, and Fed assets, but we let the other other candidate variables to be we didn't exclude the possibilities of other variables to be included in the final models as well. And then we did the test statistics if the estimated models are has satisfied the LM tests and other types of test statistics. And then we decide on the final models and did the projection as well. So we started with the bridge model by using the original specification in the Australian case. So when we did that, the estimation in terms of the R squared and adjusted R squared was fairly acceptable, I would say, but in those cases there was strong presence of the autocorrelation up to 12 lags, as you can see in the LM test. So and then with the projection, the real data showed that there was an abrupt, unusual decrease of the real GDP from the year end 2023 to first quarter of 2024. So we felt like that these models, like the bridge model, MIRAS and UMIRAS and combined models didn't capture the dynamics enough. So thanks to Yoon-jae, who's from Korea, we asked him to if he can offer any explanation. He said that during that time there was an abrupt decrease of consumer lending and household consumption, as well as the increase of imports. So that, but increasingly, most importantly, the consumer lending and consumption decrease were more pronounced in that period. So then we decided to capture that dynamic. We included the retail sales index to maybe capture the dynamics as well. And when we estimated the models, R squared have improved, even though R squared had been improved. The LM test is still showing us there's strong presence of the serial correlation. So I thought maybe we included three types of indices: industrial production index, cost P index, and retail sales index. So maybe three of them sort of exhibit the similar behavior. So like the third model was such that, and as you can see, it's even though it's slightly improved in terms of the model's projection in the forms of our mean square errors, but still because of the serial correlation, we decided to do away with the Kospi index. So without Kospi index, the result, as you can see, the serial correlation existence had been through the Brush-Godfrey serial LM test. As you can see, it has a good result. So we decided on this third models eventually, and used the MIRAS here as well. But for MIRAS, as Professor Sam told us, that the more number of variables you include in the system, due to the chosen order of the lags, that the computation would become relatively challenging. So as you can see here, we used four main variables using three third order PDLs, but as you can see, the R squared and adjusted R squared shows fine acceptable results here as well. is for the U miras. That's sort of in reverse of the miras, where the selected variables lags themselves are used in the computation of the modeling. So, but here the R squared is also in an acceptable range, but I didn't include the forecasting errors estimates of miras and U miras, but just so you can briefly tell you as for the miras model, the tile restriction was less than 2, whereas in the U miras model it was slightly above 2, so which indicates this U miras model is kind of not very consistent, if you will. So like the final projection was done using the third sets of models. As you can see from both level and change relative variables, even though it's still not capturing the full extent of the models, it had been increased. But even though we managed to clean up the LM test, serial correlation by removing and adding choices of variables, but the RMSE stats have slightly increased compared to the previous models. So that's sort of our that's briefly in a nutshell